The Electronic Playground and Learning Center has 50 exciting projects. I'm going to go through these one video at a time. This video will be the unboxing of it, which is the what you get. It does not come with a 9-volt battery. Here is the manual, the book that has the 50 projects that we'll be going through each of these. And they tell you the definitions of electronic parts and what they mean. It's a great thing, I think, for kids getting into it, or anybody getting into it, the basic electronics. So there's that. I tell you not to return it to the retailer, which is fine. There's some jumper wires. And here's the kit itself, and that's the extent of the box. Looks to be just like a cardboard deal circuit. If I had a tripod, this would be a lot better. But there you go. Here's the kit, and it is made out of cardboard. This is a plastic frame here, but this is cardboard here. A mirror kit, EP-50. Elenco Electronics, made in Wheeling, Illinois. This is all cardboard bottom. You have a tuning capacitor. You can turn the knob. It tunes the different frequencies probably. Here's your antenna. Now let's go through this. So you got a series of capacitors. There's some resistors here. Potentiometer, or they call this also a variable resistor. It's a potentiometer. There's the push button switch. Here is where your 9-volt battery will be attached to. So you'll have your negative post and your positive. Here's a transformer. It's probably a step up transformer or a step down. You have a speaker. You have 2 LEDs. Some semiconductors. You have say 4 transistors and a diode. That's pretty cool. And it showed 2 different type of capacitors here. Your electrolytic capacitors, and these are just your, I want to say they're poly. So we will start with the first experiment today, and then the next video we'll be going through the second one. Okay, the first step of this lesson, lesson 1, or the experiment 1, is going to be doing the light bulb, which you're just going to hook up the wires to the LED up here. Now, to make this simpler for you, if you notice on your box here, there's 1, 2, 3, 4, 5, 6. It's labeled, and they show 4 to 26. So you say 4 to 26. So there's 4, and here's 26. So you would put a wire between here and here. And I show you how to do this in a second. And this is going to be pretty much a demonstration how to wire it up if you're not comfortable just looking at the schematic here. It's the only really schematic they have that show the 9K resistor going to the LED. So we're going to go through this. It talked about the different parts and stuff. Everything that I've covered already about the wires and how you're going to put the wire in. I'm going to do this one hand. Basically what this does is you're just going to be pinching the wire. So I need to make that a longer wire here. And it doesn't really matter about as far as what we're doing for this one, what color you're going to use. Usually red is one for power, and black is for ground and electronic. So what you're going to do is you're going to take this here and spread the spring out like that, and now that's made the contact. And then we're going to go over here to the 10K, This is what that is. Black, brown, orange. And you're going to do the same thing for it. You're going to just stick the wire in it. If I can get it in. After you get the wire connected from the 10K, this is pin 45. I'm going to call these post pins. So this is post. After you get the post 45 connected to 55, we'll go from 56 to the positive of the battery, which is post 27. So you're making a pass from this point through here. Once this is pressed, this goes through the switch, because you're making a contact through this post to this battery positive. So next, they want you to go from 26 to 4, this is the negative side of the battery, to 4. We would use, let's go with a blue wire with this one. Okay, that's connected. And then the next connection will be the post number 3, which is on the back side of the diode, to the post 44, which is the other side of the resistor, the 10K, which makes it a complete path. So now the circuit's wired up. You have the battery here, the power supply basically. You have the post going to the switch. From the switch, when you press it, goes through the resistor. This wire here is going to the resistor. It's going to go from this side to that side of the resistor. From that side of the resistor, follow the red wire to the LED. On the cathode side and anode side, goes to ground of your diode, or the negative side of your diode, which is basically ground. So when you press this switch, you're making the path of the voltage from the positive to the negative of this battery, and it will light up that LED. As you see, I'm pressing it, the LED is lighting up. So, what you can do, the next step of the project here, the experiment, you can change the resistance to make it brighter and dimmer. The less resistance you have, say at 3.3K or 1K or 470 ohms, that will increase the intensity of that, because the resistor will take all the current. It resists the current. So it doesn't allow the voltage to go to this, basically it's the voltage divider. So if you put it through the 100K, that would be a lot dimmer. Let's try that. I'm going to put it at the 470. We'll see how bright it is and compare it to the 100K. Okay, now we have it hooked up to the 470 in series. Now you see how bright the LED is? Let's go to 100K next. You barely can see how bright this would be. And that's set up for the 100K. So, the higher the resistance, the smaller the pipe for the current to go through. So if you want to look at it like water, the bigger the pipe, the less resistance it is. The smaller the pipe, the higher resistance it is. So if you want more brightness out of your LED, you need less resistance. If you want a dimmer LED, you need higher resistance. And that's it. That's all it is for this experiment. It's very simple. Hopefully you liked the video just going through and showing you how to hook up. If you have a mistake or something, you can kind of see in this video how I did it. It's not that hard. It's very simple, just very basic electronics. I do suggest you going through here, and they have information talking about the water pumps, and they're using this, like I talked about the resistor as the box in a pipe, and they talk about like a dam type thing, and current is amps. which they go through here and they talk about it. There's all kinds of information here for, you know, kids and stuff. They're talking about currents. The unit measurements for electric current, commonly shortened for amp. So, you know, this is something that would be cool for kids. Current is the measure of how fast electrons are flowing in a wire and how fast water is flowing through a pipe. It just gives you an example, a different way of thinking about electronics. This is actually made for kids for 10 and up. So, you know, doing something basic like this is only $15. It just gets children into thinking about how electronics work. This is a very basic technology about electronics and how they work. And I know they're going to have all kinds of different stuff, the audio and NAND. They're talking about AND gates and NAND gates. This is stuff that I learned in college. So it's going to be kind of cool, you know? So there's the different projects that you go through these. We're going to go through them one by one. This will be the end of the experiment 1. This is called the light bulb. So if you like the videos, if you have any suggestions how I should improve them, leave them in the video comments down below. I will continue on to make more. Thanks for watching, guys. I'll see you next time.